Apple is going to make bubbles and stuff come off of me. I can't see my own stream. Should pull that up over here. Anyone else have a Mac that have that happen? Oh, it's going to be noise.
I didn't have it on my
Oh,
phone once when I had a Zoom meeting and I did like this.
yeah. You make some kind of motion and then like bubbles or balloons or something happens. Yeah, it gets me pretty regularly as an animated person. All right. Today is the 12th of February. We're 5 weeks in to CSE598, and we are halfway through file structs, which is kind of chill. I like 2 weeks. All right. I'm sure you guys like 2 weeks as well. A little bit better pacing. So we are here in file structs halfway through. So we just hit the checkpoint this Friday. We'll see the heap exploitation stuff launch. And that is also for 2 weeks. So moving at a decent clip. No changes there. Your memes, file structs. This one was not from a member of the class, but I'm happy to include, general community memes. Building a file struct, it does kind of feel like this, right? It's kind of what I tried to show on the last slide of the last pre-recorded lecture video. We have these pointers routing around the different things, and you can go a little bit mad thinking about it. This would be a good meme, except for the fact that, which I pointed out, this doesn't make sense. Pointing the wide data itself to execve would result in a segfault. So the spirit of the meme is good, but I would highly encourage that you don't take that verbatim. I believe the person put correct info below the meme to try it and not leak. We have great wisdom here from Sun Tzu. It says GDB interprets file pointers as an IO file struct, so one must cast it to a struct IO file plus to see the vtable address. That is great wisdom if you're going to work in the later challenges. You can't trust GDB to know much, but if you know what's going on, GDB can be a very powerful tool. I'll rant a little bit more about that in a bit. This is a new semester. Every semester, pwn.college changes things, and you end up with kind of a new meta, new rules, new instructor. Like we change how to do things. One thing that is a bit different if you were in 365 in the past is you may show up to the lectures thinking you're good. That's where the wisdom goes into your head. That's not how I do things. This is a clown fiesta here on Twitch, and you should watch the pre-recorded lectures ahead of time, and that way you can tell me what you're stuck on, and that helps me know what to do up here. When I have no content, I will duplicate it. But the pre-recorded lectures are definitely, I think, the better resource because I get multiple takes. Another difference here for this new semester, I'm frequently on the stream, and 365 is kind of stepping away. So Twitch trolls deal with me and me alone. But you know what? I enjoy the trolls. It's what makes it fun.
365 don't have Twitch, they don't stream classes.
The 365 this iteration is not streaming their classes. Yeah, they're trying a different format. Very similar to how like I used to stream office hours, right? And I've kind of steered away from that so that I can help students more hands-on and direct without spoiling everything for the internet. There's always a balance there. But yeah, this iteration, most of the Twitch stream tutorials I'm aware of are right here, right now. Despite it being a new semester, we make the same mistakes, and you'll see me make these mistakes again and again. You already have, right? The new line byte, the null byte, forgetting to set the context in Pwn tools. These are classic blunders that everyone makes every time. So, what are we going to do today? I had a slide that I hid, but there's a bit of a problem with this. If we go and take a look at how the class is doing, or just people that are solving stuff along with us, who am I? I'm 598 for the spring, and we are poking at file structs. If we go down here to the scoreboard, Now, not everyone with ASU icon is ASU. Or there's some anonymous hackers here who may be in the class, but uh, people are finishing the whole thing now, and I have another several hours of content to fill. And like even the people that haven't fully completed everything, they're moving at a decent clip, and I haven't heard a lot of questions. If anyone does have any questions, I want to try and answer that first. I'll give a moment for Twitch. If there's any questions about the file structs here. If not, I'm going to go down a rabbit hole that is not directly related to any of the currently assigned work. Because it was asked, and I thought it'd be cool. I thought I'd have more time to prep it. I was madly trying to get something that would work reasonably well an hour or so ago, but I did get it. So we have something interesting to poke at and look at. So no questions from Twitch, nothing from the peanut gallery. Okay. Camera back on me here. Let's launch a random dojo challenge because it doesn't really. Okay. Question is, how much of this do I want to just YOLO? And how much of this do I want to yoink? So one of the things that we looked at in it's not a stream if I don't have do.c. All right. See if I can type. One of the things we looked at was we said that these file structs flush out, right, when the process exits. And we just kind of took that as like, all right, that happens. Anyone know how that works?
I think it's like when you return from main, it goes into some libc functions that call a bunch of exit handlers. Like one of those exit handlers goes through all the files.
Okay, all right. There were some good words there. So the word, one of the good words, was exit handler. I had to look this up because I wasn't exactly familiar with what the mechanism was. Like I had a similar thing. I was like, I don't know, man. There's like this list of functions, and then it gets called, and yeah, it kind of works. So it turns out there's this libc function called @exit, and this is a mechanism for registering a function, as the name kind of implies, to execute @exit. All right, that's kind of cool. What we can do here, so we can say hello, and I can have some function says say goodbye, and it's going to be very complicated. It's going to say goodbye. And if we follow our man page here, we include standard lib. We say @exit, say goodbye. And I managed to compile this. That helps if I type correctly. Give it the letter. And it's over to right. Cool. When we run this, we should see hello, then we see goodbye, despite the fact that we're kind of registering this up earlier. All right. So file structs have to deal with a similar problem there with that buffer, right? But the way that file structs deal with it, it's a little bit interesting. Let me see. Let me yoink. Let's see, I just made @exit. Let's yoink this one. Let's not make this be a 4-hour class. Okay. So what do I have here? We're going to open a file struct. We're going to print off where it is. We're going to read onto that file structure, that file stream. We put hello return, right? And I want to try and perform this same thing that I just did, right? Before we had add exit, somehow I want to use this file struct to trigger that functionality. Right? User bin GCC, no PIE, because I want to have the address of that goodbye thing be static. All right, if we run our a.out guy, we get the address of our file. And if I were to print this bad boy, you'll notice that there's this chain property. I think I mentioned it in the pre-recorded stuff. What does it do? Okay, it's a linked list between different file structs, and so this is a pointer to standard error. And then if we were to print that, this is standard error, which then has a pointer to standard out. Standard out's going to have a pointer, hopefully, to standard in, and then standard in is going to have what? Hopefully, null byte. It's nothing, and that terminates the link, singly linked list. The way this exit thing works for the file struct is it doesn't register an exit handler for every single file struct. It just has one kind of global function that says, hey, we need to clean up everything no matter what, right? And so it uses I don't remember the name of the global constant. IO list all, I think. No, it's something like this. But there's a global constant that is the head of this linked list. Right now, that would point to my file struct that I just made. And then from the head of the linked list, we would navigate this chain to find all file structs that have been created via FSOP. So let's YOLO. It's amazing when the camera turns on how my brain falls out. No, I don't want that. That's from Honto's Dojo. That's going to be covered up by my head. This is cursed. Okay. User bin n Python 3 from pwn import star context arch AD64. And I just want to throw a bunch of stuff in there and kind of see what happens. See if I can make it explode. We could make it explode, right? How would we make it explode? How do you want to make it explode? Okay. That's a lame way to make it explode. Oh, you did it. It's just, there were cooler ways. chmod plus x, do that pi. And let's not do process. I want GDB to be on this thing. So hopefully this explodes and we get to see the backtrace. We continue. Okay. we managed to explode. And if we look at the call stack here, we are now in this exit, which calls, as was pointed out, this run exit handlers. And the actual kind of cleanup function here is IO cleanup. And so that is the one cleanup function that is responsible for cleaning up all of the file strings. Now, I did spend a little bit of time figuring out or thinking about how I want to demo this. And I did this on a different box that wasn't the dojo, which in hindsight was a mistake. Because don't worry, these demos do work in worst case scenario. I can run scripts and we can just see stuff happen. But remember when we talked about the heap back in 466 and we said, hey, the heap works a little bit differently. There's different metadata, right? Well, it turns out that's depending on the version of libc. Turns out that's true for like everything in libc, right? Because when libc updates. And what that means is that the exact mechanism here also can change. And so while I was figuring out how to pull off and kind of play around with this functionality, the box that I was working on last night didn't have this function. It actually is organized and structured a little bit differently on the latest Ubuntu, which I thought was awesome. So keep that in mind if you look up like how to do these type of things or just anything in libc. That the libc version and the age of the write-up matters quite a bit. And what we're doing here, if I remember right, is libc 2.31, maybe. There's probably a smarter way of doing this.
Just do VM.
No, so that would show me the file, right? But what I'm interested in a statement for Twitch is I can just run VM map. That would show me the file that's being mapped. I don't believe that would show me the actual libc version. There probably is a smarter way of seeing the libc version, but the one thing that I do know I can do is I can run libc and it will print it out right here. So this is a libc 2.31 that we're running. All right. So why did we blow up? Have we seen something like this before? Well, why does this look familiar? Probably didn't see it on stream. This RAX plus an offset of 18. I actually don't know. That isn't what I thought it was. But we're in this IO functionality, right? We're in this. What was our kind of plan of attack when we thought about V tables? And I think we were specifically looking at F-rank last week. What was the functionality that was like the userland function that was being called? That was our entry point into how do we mess about with V tables. Here, there is no F-right. If we were to look at the source of what was this thing? S2? 1? Yeah, this one. There actually is no F-right. Okay? And so that isn't the functionality that we're going into. But what was our plan of attack? Like, what were we looking for in this function or in the function that we're exploiting? Yeah, we're looking for indirect calls. We're looking for somewhere where we may be able to influence the call site. So what am I looking for when I say an indirect call? Well, I'm looking for a call instruction. Is that an indirect call? It's not something I think I can control. All right. There's that one. Yeah. I saw this, I got all excited about this part. I didn't see that it wasn't a call. But down here, we do have a call, and it is interacting. And we've seen this kind of pattern before. In fact, if you've gone through like level 7 or beyond to the vtable stuff, you might be able to, from memory, be like, hey, I've seen something like this.
the one above base 0, RBX plus.
Okay, you've seen something like this, right? And so you might be like, okay, this looks a little bit like something I've seen where I'm offsetting, if I remember right. Now let's just find out. Let's set a breakpoint there and carry on before I say nonsense. So where am I? I am at, yeah, what function? Is that hex or no? That one is not hex. Plus 208, you said. Now this will not work if I just do this.
It's not loaded.
Right. The statement was because it does work. No, it didn't. Okay, we sag faulted. Good. I like it when the computer does what I think it should do. Right. This doesn't work because that symbol hasn't been loaded. The way that PwnTool deals with this is it breaks at _start, then tries to run these commands. And at the time that it runs these commands, that doesn't work. Like that symbol doesn't exist, so the breakpoint doesn't get set.
Breakpoint, if it does exist later when it does get loaded, there's something that can.
There is supposed to be, right? You can set a breakpoint in a symbol, and GDB will be like, hey, if I find it in the future, I'll break there. I have not ever gotten the Dojo's GDB to do this. So I have a workaround. We can break at main, right? And we can just script it. We just say, all right, well, when we break at main, let's set the breakpoint, and then let's continue. And then we'll throw a continue down here. So at start, we set the breakpoint at main. We continue. When we hit that breakpoint, we run the stuff inside the commands, which sets the breakpoint at IO flush all lock P plus 208. Then it continues from main, which should hit the breakpoint automatically. Did I get where I wanted? I am right there. Somebody made the comment to me. I said something about GDB scripting. They're like, here's some Python library. It's like, yeah, like it's cool, but sometimes you just need that low level, just dirty, grimy GDB script. So we're interested in what's going on here. RBX should be a file struct. We got 215D2A0. We fire up here, 3B2A0. Is that the same thing? That is not. Okay. So what is this? Let's just pretend it's a file struct. Okay. So, well, does this mean it's a file struct?
Well, it has our input from what we get for the file struct.
Okay. Yeah, it has our input, so hopefully that informs us that it is a file struct. But for the record, I could just cast RSP as a file, and it doesn't mean that what's chilling at RSP is a file struct. GDB will let you pretend anything is anything.
Yes.
But I really don't want a file struct, as was pointed out in the meme. I want an IO file plus. I don't remember what RBX. At which point we do control this vtable. And as I learned yesterday, or not yesterday, last week, and it forever changed my life, the power of the aux, right? I think about the aux now every time, right? Like last night when I was working on this, I was just like the majestic aux. IO file plus struct. We see that at D8 is the vtable for that. Does this mean that I'm doomed? Like something doesn't add up here, right? Because what was the offset that we're looking at? RBX plus A0. Is this just all over? Do I care? Do I really care what the struct is? This is one of the things that hopefully, as you move through later through the material, how to do with like overlap. Do I actually care what the struct is or how it's laid out in memory? No, this is all pointers and offsets. Do I control this pointer?
Yes.
Yes. So that means that I could control what value gets loaded into RX. How do we want to do that? Do we know where it is? We said a whole bunch of A's. We said RBX was not. It has RAs, right? RBX was 215 D2A0, which is.
Oh, it is ours. Just look at the wrong.
Oh, okay, yeah, you got me there. So it is where the file stream is. So could I just throw in A0 bytes and then some pointer? Why not? Yeah. Right. It's all just offsets pointers. We got to start thinking about memory like that. So let's try and be somewhat organized. We'll give hex A0, not 0A. A's, and then where do I want this to point to? Where do I want to set RBX to? You guys are making it up here. We see in the next line, REX plus 18 is loaded into something. Do I want to mess around with all this? Or I just want to make it a valid pointer and then go? There's one thing that we're doing right now that I think is a little silly. So I don't have to necessarily know what functionality is going on there, right? I really only care if it's a problem. Things are more likely to be a problem because we decided to just yeet a whole bunch of eggs. Assuming that your IO isn't going to stop it, a good reasonable default value is just use null bytes. You're less likely to trigger weird functionality, right? And then, since we don't have an opinion on where to send this, we will send this to the only valid memory location that we know, right? That we have to, or not that we know, because it has no PIE, so we could go to BSS. But the only area that we can control right now easily. But we have to capture that. So P receive until at, let's say FP adder, P received line, give it the old -1, see if I know how to index to an array today. Make it int, base 16. And our payload will have a P64 of that address.
Or a receive line. Chris.
Thank you. And we send our payload right there. Now this will probably still explode, but hopefully will explode a little bit further down, right? Because all I really care about is, can I get to that indirect call that I control? If I can get there, good things have happened. Something happened. So it exited. Says it exited 0 up there, and down here in GDB, it is very grumpy. So maybe my null bytes were not the answer. Maybe we do want A's. Oh, we got, I don't know what that meme is. Surrender flag? A little green dude with a white flag. Give up hope. It can't be done. Yeah, I don't blame you. Okay, so is this where we were? We seg faulted. How did we seg fault? I thought we understood what was going on. We had our A's. Life was good. Okay. What is RBX? Did I not go early? We are seg faulting because of the A's. Because of RBX here. Do we see where RBX is set? No, it's deeper down the rabbit hole than I would trust.
You can break at this point. Right?
I could break what?
You can break at this point right before it's checkpoint.
You're correct that I could break here before it's seg fault. What I'm looking for, I'm starting here and I'm looking up the next like 5 or 6 assembly instructions, and I'm saying, hey, where does RBX come from? Right? That's what I care about. And it's once you get to something like this, you actually don't have a guarantee that like this was the next thing that happened when you're staring at assembly. Like it could jump from somewhere up here and end up going right here and then execute. Right? I can't make the assumption that this is just a linear, hey, we didn't jump here.
Should break at the start of this function.
So we could do that. I'm gonna rely on an old friend. All right, we haven't used this enough. Okay, before I learned about the ox, me and Cyclic were tight. All right, Cyclic should get Cyclic should get a little bit of screen time too here. You can't really judge. And now we managed to trigger some other functionality, right? And this has to do with, we don't necessarily understand the control flow here. No bytes were cursed, A's were cursed, Cyclic is cursed.
When we sent 100x of A, we got to the 208 line, but now that we're getting less A's, why are we sent all different places?
Why are we seg faulting in different places is the question. It's a good question, right? So we can, let's see if I can do this. This will be exciting. We can find the source for this thing. I believe it's hiding here. What am I in? Like IO cleanup? I think I can find that here. Nope, that's going to be in libc then. Can I find this? So some of them are in glibc proper, and some of them are hiding in that thing, and I don't remember what is where. RIP. Okay. So you can find IO cleanup, and this is just dealing with libc in general. You can't trust it. IO flush lock all. Look, it doesn't look the same because we're not on the right version of libc, right? This is almost the rabbit hole that I was in last night. We're on 231. Is it just gone? Okay, now we have that, right? This looks correct. And so we could go in here. Well, that says there's no definition. Dang it.
Mysterious.
All right. Well, it's probably in the other But we got problems, right? Well, what else could we do? I can tell you what I did when I was working on libc 2.41. I grabbed the libc and I pulled it up in Binge and I just looked at a CFG until I found what I was looking for. Is it still? Oh, Binge is working hard. But we need to figure out like why these bytes are impacting Buffalo, right? And it does seem kind of weird at face value that okay, 6.1 is good, 6.2 is bad, cyclic is this, null, right? What the heck? See, this was me last night. And I was looking at where were we? IO cleanup. Ah. But I was looking at something like this and zooming out and being like, okay, what byte where is causing this? Where do I need to go? Right? That's how I did it. Is that how you guys want to do it? You gotta have an opinion, man. You gotta have some skin in the game. Okay. So we like the A's. Yeah. What was our function? Just it's this guy right here. Flush all lock P, right? Let's get rid of the 208. So we'll just start at the top. It can't be too big, can it? All right. That doesn't look like anything interesting. Okay, we have our, what was that first track? Was that anything I control about? No, it's not an A. What we'll find here, there it is. No, is that it? List all lock? No. We're going to find that magic global in here. All right, I don't really care what it's doing. It's not related to me. Not related to me. Where is the part that matters? Okay. I thought we were there. Did I just skip it? No. But you see how like trying to find this from scratch can be pain. Okay, is this related to, oh, I swallowed it now, didn't I? Oh no.
Check it.
All right. So we got there. Let's see if we can be smarter. Let's take RBX minus 8. Okay, that is definitely not our A's. So RBX is the start of our A's, and it is going to move C0. C0. It's checking this mode. I don't have to particularly care about the mode. I just need to know, do I want to pass this check or not? Right now, EDX is all right. Yeah. Is 0. And so we do not take this. If we examine like 40 instructions from where I'm at, is that what I want to do? I want to take this jump. Where am I trying to go?
That's what we said. Around the 400s.
Okay, so you think
We do want to take.
we do want to take this jump. That's at C0. So we want more A's.
Or just non-zero values, but
Okay. How about some B's?
yeah.
What do I need? Hex 20? That gets me there. I should have saved that spot. This is why GDB scripting is your friend. Let me know. You see it. But like from scratch here, this is some pain, right? Because it turns out, if you don't have an amazing video that tells you where these interesting points are, trying to figure out all of these paths and requirements is a little bit tricky. I'm aware that there are smarter ways of exhausting a set of requirements here. But all right. PDX. What happened? Why don't I get my B's? I was a believer in the B's. RBX. There's my A's. And it's looking for C0.
Go up to it, but no.
Oh, yeah.
Not really.
Mhm. Anyone remember what that offset was? They need to add that to the mistakes meme.
We're gonna do it again.
Just set like a, I don't think set like a output file for GDB, so you have like a log of all of your.
Oh, I need to figure that out because I make this same mistake pretty regularly, as you can see. Come on. Come on. All right. We did it. All right. We have managed to set that value. All right. Now we do jump.
Well, that's where we want.
And if we examine 20 instructions from right here, is that what I want?
Yeah, A0.
Yes. Well, okay, you just see A0. You're like, hey man, A0 is awesome. I don't know this. Okay. Only thing I really care about, like when I'm thinking about this, is does this get me closer to this? Does this get me closer to this indirect call? I really don't care about the structs. I really don't care about anything other than that. We have solved one constraint, right? One more constraint to get us closer to there. Now this is probably going to blow up, right? Because if we examine the giant hex at RBX plus OXA0, does that make sense? Yes, because we put B's there. So what do I want to put there now?
The buffer address, the file pointer address, which points to your B.
Okay, let's put our points to our A's. You want what do I call it? FP adder? P64 FP adder. And then I need to drop this by 8. That is going to make this pull in A. I'm going to save us another trip through GDB. What's going to happen next? We're gonna blow up again. So how do we want to fix that?
Some said.
Put something where? What is our problem?
It's gonna drive you. It's sexy.
All right. What is REX currently?
that point, bunch A's.
Okay. So what do we want to make RAX be? Some valid memory address, right? Well, we really care about RAX plus hex 18. And we said that is the beginning of arrays. I don't trust myself to do math, so I'm just going to dynamically subtract there. What do we want instead of A's here? Probably something relative to the area we control. We said it's going to access whatever I put here plus what? Was it 18? Hex 18? All right. So what do I want here? This is a choose your own adventure, guys. We can put this pointer anywhere you want. We can put it right here. You want it right here? Okay. It can go right here. It's not all right, but
Change it later.
yeah. After we take another long drive down the dusty GDB trail. Okay, so if we set it to be pointing to essentially itself, right? It's going to take that address and then add 18 to it, which means I need to modify this because I want to control that value now, right? I want to control what our CX resolves to, don't I?
CSE598.
Well, RCX is controlling this right here, right? And do I want to satisfy or not satisfy this constraint? Jump below equals. And it's going to jump to 270. Does that get me closer or further away to my call site? That gets me further away, right? So I want to fail whatever this is.
It's referencing ourselves, RX. So
All right, so it's checking if RCX is, I'm reading this backwards. It's checking if the pointer that's at RAX plus hex 18 is behind the pointer RAX plus hex 20. Now this seems kind of arbitrary. This time we can reason about it from a struct standpoint. Anyone want to take a shot at it? Bring in the aux. We were interested in offsets hex 18 and hex 20. Why did the aux fail me? Oh, I wish it was just flag. Hex 18 and hex 20. What is it doing? It's looking at the base pointer in the right base. It's checking if there's anything in this buffer to flush out. If there is, then we need to go do that work. So that makes some sense on as far as what it's checking. And was I good with am I good with my A's? Bring back our context there. Boop. All right, let's just fire and let's rock and roll. Well, let's save this address. Let's definitely do that.
because this is still done these.
Oh, you're saying this our RAX is going to make a seg fault? Do we know the secret value? Who is in RBX? Bam. Let's set RAX equal to, right?
Already simple.
Dang it. It would have been nice. All right, it would have been nice. But we got the address. So. Oh, we didn't do the shenanigans there. BA times. Okay. That should resolve. That looks like a valid address. We do the comparison. Right now, we are going for the long trip. So we do need to fix up this memory to make it work.
What are the values being compared? Like,
Right now, the values being compared were RCX, probably A's, and I bet the other thing is A's as well. REX plus 20. And so we're equal here. Right, but it was 18 and 20, so maybe we can fix this up. If this is at 0 to 8, I need to get to 18. Somebody's going to tell me I can't do the math because I probably can't. That gets me to plus 18.
that gets you up to.
Right, up to it. Let's P64 this with which one? I want what to happen. I want what's at 20 to be bigger than what's at 18.
So send these instead of these. And have an A's and put these. Or just.
All right. I'm going to keep it simple. All right. Little, big. That was my requirement. Now I haven't fixed this up. So what do I have to do here? I need to subtract another hex 10 minus another hex 10. This is going to become just some insanity string by the end of it, right?
So you have payload plus equals.
Yes. That one there. We're good.
Sure.
Computer science. You gotta just be a believer. All right. We step. All right. It's way easier when you can do the math. I can't, which is why I'm good at GDP. All right. So we passed that that hurdle. We're getting close. We can almost see it. Just blindly march forward. Right? Because I don't really care unless it's a problem. I don't really care what happened. It wasn't a problem. Right? We made it to this right here. Do I control that value? No, that's not what I want. I want to print REX. Is that what I want? What am I doing? Let me look a little bit behind it. Looks like we don't control that right now, do we? Because it's not A's, it's not B's.
Yeah, right. Plus VA, which I think is the offset to the V table in the file struct. So now we're probably calling the overflow function or something.
Well, you're right that this is a V table thing, right? Like we've seen this shenanigans already, but we should control RAX, right? Is our thought.
So that the file structs V table right now.
If it is the file structs V table, are you saying I haven't thrown in enough bytes? I happened to look this up.
Don't we need to go through the file struct V table first to get to? Right? Wasn't that the chain we go through the shifted overflow in
Yeah.
file struct V table? Yeah.
Yeah. So you're conceptually you understand what we need to do, right? We need to try and get this thing to go through the V table to call. Right now, we just really like, what is it? W file overflow, right? That's our tried and true solution here. But right now, are we going to end up there? No, right? And my statement was, in order to get there, this does look like a V table pointer, but can I influence this? Can I control this? Is what I'm trying to ask myself right now.
Sorry.
It does not look like. Was this all for naught?
Don't we just need to corrupt the V table pointer? Why would we- We're just not setting up bytes to do that right now.
All right. Can I use cyclic? That's how big a whole file struct is. I happen to know this number. But I think it's worth, while it is a little bit tedious, it's worth seeing this process of being like, hey, I see something I saw before when I was doing this vtable stuff. It's a different vector. It's a different function that we're interacting with, but we see this similar pattern, right? You can do this type of vtable shenanigans with all sorts of IO functions. Yeah, now you see it right there. And so we fell into the vtable check. Or was it lookup? What's the
Yeah, so,
Jeff and PwnDebug have a built-in cyclic lookup. I don't remember what it is apparently.
you do apropos cyclic.
Oh, it's one of these. I want to say it's one of these. Nah, whatever. I know you can do it at the old terminal. We're only 16 bytes away. So we'll add some more padding bytes there. And now we have a vtable pointer that we could override. And does anyone want to see this go all the way through? Or this becomes the same exercise that we had last week? We good? Cool. But we see that reduces to kind of the same thing that we do in level 7 and the later vtable challenges. And so if I have this file here, which is the thing that we were running through, and I have an exploit that does all of that. All right. See, I did the same thing with all of my fancy breakpoints and marched my way through all of this. Just so, and watch it not say goodbye. That makes me sad. I blame compilers. Um, oh, wait. No, that's good. Why do I not see it? Gosh dang it. Gosh dang it. You could do it, and you could trigger that that goodbye. And we should have seen hello, goodbye. The easy one I didn't test on the dojo. It was the hard one that I did. So you will have to believe me that that exists. Now you can imagine a scenario that is like this. Here, I don't want to just trigger one functionality, right? I want to trigger more than one action. And this is where we get to something that's a bit more interesting than the vtable that we started with anyways, right? Because triggering functionality from the vtable and just calling one function is essentially what you did with level 7. You're just doing it from a different entry point. Well, what if I want to try and get the flag from here? Can we do it? I need to call 3 different things. How do we do it? All right, the chain is important. What am I going to do with the chain? And I need to go and find standard in and standard out and mess up every single one of those? Somebody's nodding. That sounds like real pain. It's not what I did. That's one thing we could do, right? We know that this first file struct will have a chain that points to standard in, right? But in order to get to the v table of this first one, I have to clobber that chain value. So I would have to know what libc is ahead of time. Now, this particular challenge does leak outputs, which is going to give me a libc leak, which means I could calculate where standard in is. So I could fix it all up. But then I have to overwrite something that is on the heap here, and I have to go hunting for standard in. That sounds horrible. Any other ideas? I think it could work, but that sounds like a lot of work. It's still a lot of work. It sounds like more work. What else could we do? What do we know about this chain? We marched our way a little bit through it.
It points to next file structure.
It points to the next.
We could just make it point to a file structure we made.
Yeah. Right. It doesn't need to be real, right? It just needs to. The pointers just need to resolve. That's all that matters. And so this turns into building a primitive that is, I overwrite the file struct, I do the full vtable thing, and then the chain points to my next file struct that is going to flow all the way through the vtable, go to the wide thing, circle on back, and call the next function. Right? And we have to make all of those pointers work. And just like how we march through this initial one, we have to find every edge case where something explodes.
If we took care of the exit of one file structure, why do we need to do any more work? I think just one is enough. Like, wouldn't they call the same functions every time?
All right, I'm going to answer that, but we're going to take a pause. We're going to take our break early. All right, we had a nice off-stream discussion there for a moment where somebody reminded me about the pain of this course and how everything turns to ROP. But ROP wasn't the question here, right? That wasn't the impetus for me seeing if we can do this on the dojo. So we have this binary here, and I have now 3 different functions that I want to call, and I can't just get the flag from one of them. Am I in practice mode? Good, I am. I'm not going to set UID this thing. Instead, I'm going to chmod the flag. Now, I wrote this challenge, or I hopefully this no shenanigans guy. All right, see if I can find him. Yes. Is this file? So if we user bin GCC, no PIE. Oh, no, it's cursed. User bin GCC, no PIE. Oh, no shan. I just called no shan because prior to the break, I was saying that, hey, there's like problems that you can you have to try and like deal with and clean up. And that was when I disappeared to the netherworld on screen. And my statement during the break was these functions that you call into are going to change the state of registers, right? If you override the V table, you go in and execute, for instance, open flag. This is going to change what's in RDI and RSI, as well as probably REX, right? And then you're going to jump back into the cleanup function, and those registers need to make things not explode. And that may mean that you can't call certain functionality because it interacts with registers that are not your friend. You'd think calling conventions would take care of all of this, right? Maybe I just wrote a horrible exploit, but in theory, this thing will fire off now. We built it. We're going to disable all my breakpoints. I just want to see flag. All right. You see the practice flag. This did in fact fire off and go and get the flag. All right. It's good when a demo works. And so the question is how did that happen? We have all of these convenient breakpoints here, right? And so I'm at the top of this IO flush all lock P. This is the function that is iterating through our file structs. And let's see, I think my exploit code, I print out all of the structs that I write. And I also print out the address of my first guy here. And what we see is that this first file struct does not point to, for instance, standard in, standard out, standard error, anything else that was there. Instead, I am making up my own chain. I'm building my own linked list of file structs where this address here happens to be right after my first one. And so in memory, what I have here are like 3 or 4 file structs just sitting right next to each other where these chains point to the next one. We go into our overflow because we successfully overwrote the V table. We go into our dualic buff. We end up in open flag. we finny our way back up to flush all lock P. This is where that loop is, where we should be able to see the chain being incremented here. Right. RBX, I believe this is our spot. We examine the giant hex of RBX plus 68.
That's the next
You just know it is the next one. So this is where I gotta try, man. All right. This is where we're grabbing the chain pointer from the current file struct, and then we're testing to see if it's null or not. And then if it is not, then we go for another loop. Right? We go to the next file struct, which we have managed to overwrite the V table, which goes to W file overflow, goes to our dualic buff, except this time we end up in read flag. All right. And so instead of, for instance, ropping, which I agree is probably the simpler solution, you can build other kind of weird machines. And this is like a consistent theme when you look up like really cool exploitation. It is taking some kind of functionality in a piece of software and abusing it to turn it into kind of your own way of computing. Where here, every action that I'm doing requires me to go through this convoluted vtable wide data vtable execute something. Where ROP is a bit more straightforward, where we're just, pop and chill things. What's the meme? Being a chill guy? I'm just a chill dude. All right, I got to try, man. And of course, we go through it one last time, which is how we then call right and get the flag there. All right, we see it get flushed out. You do not have to do this in this module. I now have to think really hard about how to stop people from ropping. Because I would like to have challenges that play around with this concept, as well as one other thing that I think is kind of interesting, which is just going to be a side note that I'll leave things with real quick. So normally, when we think about this chain, we have, see if I remember this, _2, 1. Yes. The standard in exists, right? And it's chilling in memory. Standard out exists and it's chilling in memory. Standard air exists and it's chilling in memory. These are not necessarily in this order, but they're all roughly near each other. This, if I remember right, the buffer pointer, so we can see it. What did I print? Standard in? Oh, it hasn't read anything, so it hasn't allocated any space yet. But from here, it is possible to overwrite from one file struct into another, right? Because they are located next to each other near memory. This is there's a number of kind of interesting exploit paths where if you can manipulate the buffer pointers of one of these into the other, you have an opportunity to kind of mess around with this. And that's in a less contrived scenario than me just giving you, hey, overwrite this file struct. Man, I was going to add challenges and you had to ruin it.
I wonder, I've been thinking, like, when is there supposed to be like userland CFI support? I'm pretty sure it's already merged into the kernel. I wonder if we can enable it for challenges.
That's hardware, isn't it?
Yeah. But most Intel systems for like quite a while support IBT at least, like the forward edge one where you have to go to FBR64.
Yeah. We talked about, if I remember right, our limitation was hardware. Although I have new hardware, We just aren't using it.
Yeah, I guess the Dojo doesn't seem, the current CPU doesn't seem to support it, but
Yeah.
any more recent.
No, I have like a year-old server. Like there we have hardware that's very new specifically for that type of reason. We just don't have right now. The infra doesn't have support to correctly send people where they need to go. But anyways, this was our little rant here. One day I will stop you all from robbing. I want to believe. Nice chill week. Most people have things done. Does that show you in theory how this FSOP, so we're going to call it FSOP? Yeah. FSOP works. All right. Twitch is just chilling, so we'll leave it there. This Friday, we'll have the heap, kind of going deeper in the heap. And that should get us pretty close to spring break. All right. Goodbye. Good luck, everybody.